For 20 years, the global enterprise has operated on a single assumption that to process data, you must extract it from its source and hoard it in the cloud. This logic birthed the centralized data lake, colossal server farms designed to store exabytes of historical data, under the theory that more storage eventually equals more insight. But these lakes are physical. They require a constant, massive draw of baseload power from the electrical grid simply to keep that historical data accessible. As a result, data has transitioned from a digital asset into a physical liability, consuming the very electricity needed to power the next generation of computing. That collision is happening now because of agentic AI. Unlike the static models of the past, agentic AI requires localized high-speed compute nodes to function in real-world environments. This map shows the conflict. The legacy data lakes are consuming the available grid capacity, leaving the smaller, localized AI nodes starved of the energy they need to spin up. This isn't a theoretical shortage. Currently, over 3,000 gigawatts of global interconnection queues are stalled, effectively frozen by a lack of available power. This is the energy paradox. Hyperscalers are in a position where they must choose between storing the records of the past or powering the intelligence of the future. The solution seems simple. Stop moving the data. If we process information locally at the source, we don't need the energy-intensive storage of the cloud. We call these local environments the edge, the servers and networks living inside individual corporate firewalls. But for decades, this was impossible due to the edge trust paradox. Large enterprises couldn't push their compute power outward because local edge environments were considered inherently insecure. Without a way to trust the security of the local node, the only safe option was to pull the data back to a central vault. This single security roadblock is what forced the world into the centralized, energy-wasting infrastructure we have today. P3C resolves this by changing the direction of the flow. We call it the Layer 3 reversal. Instead of extracting raw data up to the cloud, the algorithmic query is pushed down to the edge. This is handled by Helix Mesh Processors, secure nodes deployed directly inside corporate firewalls globally. Inside these nodes, the raw data is processed locally. The system extracts only a clean cryptographic pattern, the actual insight the company needs, while the raw data never leaves the premises. Once that pattern is generated, the heavy raw data is immediately destroyed. By calculating and then destroying the data at the source, the enterprise gains the same insights it would from a data lake, but without the cost of storing a single file. When the cryptographic pattern provides the same utility as the raw file, the need for mass raw data storage becomes mathematically obsolete. As the requirement for bulk storage disappears, the economic incentive to maintain cloud data lakes vanishes. These facilities, once the center of the enterprise, become redundant overhead. The physical impact is immediate. The base load power previously used to keep that data alive is released back into the global grid. This map now shows the energy being rerouted. Without the drain of the legacy storage centers, power flows directly to the localized AI nodes, allowing them to activate. This shift aligns global power distribution with the actual demand for AI compute, moving energy from the storage of the past to the execution of the future. By solving the security flaw at the edge, we remove the bottleneck on the grid. The energy crisis for AI is addressed not by building more power plants, but by changing how data moves. This is the architecture of Layer 3.